Welcome to the PluTech channel. Today we have a topic to discuss about how cheap AIs are stealing data from any recorded screen. Don't miss the chance to join us and share your opinions with us. AI researcher Simon Willison was faced with a common challenge: adding up billing information spread across multiple emails. The task seemed straightforward, but manually inputting the bills would be tedious. Instead, Willison turned to an innovative approach called video scraping, which involves capturing a video of a person's screen and running it through an AI model, similar to ChatGPT, to extract relevant data. What might seem like a practical solution has revolutionary potential. Willison demonstrated how AI assistants could eventually visualize and interact with what's happening on users' screens. He shared the experience on his blog, where he described how he recorded a 35-second video of himself browsing through emails with the desired data and processed it in Google's AI Studio tool. This platform offers access to models from the Gemini 1.5 Pro and Flash AI lines, allowing video manipulation to extract information. Not only did the AI accurately extract the values and dates Willison needed, it also organized the data into JSON format, which he later converted to CSV for use in spreadsheets. Surprisingly, the cost of this process was negligible, less than 1/10 of a cent, using just 11,018 tokens. Since Google offers free use of AI Studio for some use cases, the analysis cost nothing. This experiment highlights the power of multimodal models like Gemini and GPT-4, which can process a variety of inputs, including video, audio, and text. By converting any multimedia input into tokens, these models can make predictions efficiently. While LLM is still the most popular term, many experts suggest that token prediction models, TPM, may be a more accurate term for these systems that work with multiple data modalities. The ability to extract visual data quickly is especially appealing to Willison, who also works as a data journalist. In another application of video scraping, he recorded a 7-second video showing books on a shelf and had the model list all the titles it identified. This technique is valuable because it converts unstructured data into a usable format, something that often proves challenging for journalists. The potential of video scraping lies not only in its efficiency, but also in its resilience to traditional data extraction barriers. As Willison points out, even websites with anti-scraping protection or advanced authentication can't prevent video from being captured from the screen while the user manually navigates through content. This control puts the user in the driver's seat, deciding exactly what they want to share with the AI model. However, this capability raises ethical and privacy concerns. While tools like AI Studio offer impressive results, they also open the door to malicious uses. Companies like OpenAI and Microsoft are already experimenting with models that can seethe a user's screen. Microsoft, for example, demonstrated a prototype called Copilot Vision, which can interact with the interface of applications, such as ordering pizza on confusing websites. However, video processing has so far been computationally expensive, which has delayed the wider implementation of this type of functionality. Even with these challenges, companies like Google and OpenAI are heavily subsidizing the costs of AI, suggesting that these technologies will become more affordable over time. Models like Rewind AI on the Mac and Microsoft Recall for Windows 11 already feed databases of screenshots, but they introduce concerns about storing large amounts of personal data. This increases the risk of privacy intrusions if these repositories are compromised by hackers. Despite the concerns, Willison believes the video scraping technique is still safe if users maintain control over what they share. He argues that the ideal would be a local AI model, running without a connection to the cloud, which would eliminate the risk of data exposure. Microsoft Recall already operates in this way, but it requires cautious trust from users. For now, Willison is content to use the technology selectively, when necessary, and seems optimistic about the future possibilities. With a career marked by innovations, including coining the term rapid injection in 2022, Willison continues to explore the boundaries of AI. His interest in new applications of video and AI suggests he's at the forefront of technological change. If the past is any indicator, his discoveries are likely just the beginning of a new chapter in the interaction between humans and AI, and perhaps it's time for all of us to follow this evolution closely. Don't forget to subscribe to our channel, like the video, and share it with your friends. Your interactions mean a lot to us and help us grow. See you next time.